Hello, friends. Today we're going to read about plate tectonics, and you'll notice the heading up here. As we read, I want you to use those text features we have learned in Miss Gallo and Miss Lamas's class. I'll begin here. Has anyone ever told you to sit still? Do you know you can never really sit still? You have probably already learned that Earth is constantly moving through space, but did you know that the ground beneath your feet is constantly moving too? Have you ever noticed that the continents on Earth look like pieces of a puzzle? You are not the only one who has thought about that. More than 100 years ago, a man named Dr. Alfred Wegener thought that the continents once fit together. He said that a force caused the continents to drift apart over time. Once scientists figured out what the force was, the theory of plate tectonics was born. You'll notice that we have a map here. The continents look like pieces of a puzzle that would all fit together. And then you have another map here that's not very familiar today, but in the past, this was called the supercontinent Pangaea. The caption here says below, shown is the supercontinent Pangaea before it broke up and the continents drifted apart. And this is a photograph of Dr. Alfred Wegener. Dr. Alfred Wegener came up with the hypothesis of continental drift, which led to our theory of plate tectonics. In this little paragraph, you're going to notice a lot of italicized words. Those are important words, so pay attention. Earth is made up of layers. The top layer is a very thin layer called the crust, and it is made of solid rock. Below the crust is the thick layer of molten or melted rock called the mantle. It is not an actual liquid, but it can move and shift around very slowly. The solid crust is broken up into large chunks called tectonic plates. These plates float on top of the mantle. Think about a float in a swimming pool. And in this photograph on the side, the author included this here so that you can easily imagine that. Float in a swimming pool. Does the float stay in one place? No. It slowly moves over the surface of the water. Tectonic plates are moved around by the magma underneath them, much like the pool float is moved across the water. Stay tuned. This motion causes some interesting things to happen. Scientists have figured out the borders around all the plates on Earth's surface. They have given names to the Earth's tectonic plates. This map shows the major tectonic plates in their present locations. Many of these plates are named for the continents or oceans on which they are found. Here is the map. And you'll see South American plate. You'll see the African plate here. You'll see the Philippine Sea plate, Australian plate, and you can pause this so you can take a look yourselves. Tectonic plates interact at plate boundaries. Tectonic plates are constantly moving at different times. Some plates move faster than others. However, even the fastest plates move only a few centimeters every year. That is about as fast as your fingernails grow. Tectonic plate boundaries are places where the edges of two or more plates meet and interact with each other. Earth's plates are all moving at different rates and in different directions. Some move toward each other. Some move away from each other. And some move side to side of each other. When big chunks of crust interact, some changes to the landscape can happen. We can use what we know about these changes to figure out where the plate's boundaries are. What do you think? What are the effects of plate movement? Here's mountain ranges. Look at the topographic map to the right. Do you see the yellow bumps? Those are mountains. That's right here. Take a look at the second map of tectonic plate boundaries. See how the mountains were formed right along the area where two plates meet. Those mountains were formed by the plates pushing rock together over time. See over here. Did you know there are mountain ranges on the ocean floor? The image to the right shows the Mid-Atlantic Ridge. It is underwater. Do you notice a relationship between the location of the ridge and the plate boundaries shown on the left?